No matter what business you're in, digital transformation never stops. At Verizon, we keep companies ready for what's next. We weave security into their business, virtualize their operations, and build AI customer experiences. We also keep them ready for the next big opportunity, like 5G. Almost all of the Fortune 500 partner with us. When it comes to digital transformation, we're here and we're ready.
Hello, and welcome to Explore Adventures in the Underland, Forensic Techniques Against Hackers. If you're joining us live, our speaker is in the Slido chat discussion answering questions right now. For audio-video issues, click the technical support button below. I'd now like to turn it over to Paula Yanaskevich for the presentation.
Thank you so much for the introduction, and good morning, good afternoon. I hope you are doing well. Let's jump into a bit of a forensic subject, but first let me introduce myself, Paula Januszkiewicz. I'm the CEO of Secure, and I've got 15 years of experience working in cybersecurity field, delivering penetration tests. I've got also access to the source code of Windows, even though I don't work for Microsoft. I've got a role of Microsoft Regional Director. So this is pretty much my background. And within our team, being placed in 4 offices, New York, Switzerland, Poland, and in Dubai, we are pretty much taking care about cybersecurity of our customers. So we've got forensics, and when we look at the subject, this is a very exciting subject because within forensics, we've got the possibility to perform, first of all, evidence gathering and then investigation about what happened. And in our team, and including myself, we are participating in various types of projects. There are plenty of stories to talk about. So let me share with you at the very beginning the story where basically we learn that research makes sense. So long story short, I've got a friend and he's a developer. He was asking me where it's possible to meet someone. Yes, so I recommended some dating portal, so to say. And he registered himself and he arranged like a chat discussion with some lady. And he went for the meeting and he was completely disappointed because the picture that he got, basically, it wasn't the same person that was on the meeting. So he came back to me and he asked the question, okay, so what am I supposed to do? So I said, arrange a Skype call. That will clearly help you to avoid that kind of situation. So he did that. And there was a lady, she was really nice and so on. So he was like, okay, let's meet up. So he went for a date and then he comes back quite disappointed. And I'm asking what happened? Yes, that could work out pretty well. And he was like, no, because who was actually on a Skype call? That was this girl's sister. And eventually she was too ashamed to be on a Skype call. So that was just a different girl. So I said, you know what, then deeper research never hurts. And when we apply that story to whatever we've got within the memory of the operating system, that works out pretty well because within the memory investigation, and this is the first evidence that you gather, not the disk, but the memory, you've got a possibility to extract lots of different type of data. For example, we've got the processes list, we've got different files, we've got a possibility to play with different DLLs. So in general, you can learn a lot what happens, and whatever works in general, and this is the rule, you're going to find in a memory. That's why performing a memory dump, it's so important. Whenever we look at that approach, what I would like to show you guys is the possibility to extract files from the memory dump. And let's start with something not trivial, if you don't mind. And this is actually a situation where we were having real issues during the project because our job was to actually extract the memory content and the files that were supposed to be later used within the investigation. Let's have a look. In one of the projects, we had a funny situation where we were supposed to extract files from the memory of the operating system of someone that eventually was committing a crime. And the interesting fact is that not only we were supposed to extract files that could bring some meanings, like maybe remains of documents and so on, but also we were looking for EVTX files that were not saved into an original file yet. And that is extremely difficult because EVTX itself, it's super hard to reverse engineer, but we did that. It took us actually over 6 months to do it, but eventually we are there. And interesting thing is that we were able to analyze these files, so the EVTX files, make them not corrupted, make them consistent, and then we were able to read portion of the log file that could help and helped a little bit within the whole investigation. So let's have a look how we can do that. So over here, we've got volatility and we've got a dump file, analyze DMP. We specify the profile over here. So for example, that's going to be this one. And in order to be able to extract files, we have to find out which process is actually responsible for maintaining these files. Well, not only this, because you could go to the address in a memory address space, but eventually when the process was there and it was processing certain types of files, for sure that process would have handles to these files. Now, because these are the EVTX files, if we think about what kind of process could have handles to EVTX, that will be clearly SVC host, because that's the one that hosts the Windows Event Log service. But the funny part is that even though we know that, question would be which SVC host, because there are many of those. So in order to identify SVC hosts that we have to look at, first we need to do DLL list like this to get us DLL, let's just stream it to DLL.txt, to get us all of the DLLs loaded, including the ones that is responsible for Windows Event Log service. And this is how we will be able to find SVC hosts that is related with that DLL. Okay, so let's have a look. So DLL.txt. And over here, we've got a pretty large file where we are looking for the WEVT SVC. So that's the one. And we found it. And that's this one. So which SVC host is this? 848. Okay, fantastic. So we can copy that process ID. And now we can go to the next stage where we're going to be actually digging into the extraction of the files. And what's so exciting about that is that you can do it not only with this particular types of files, but in general, you can do it with anything that you eventually going to find meaningful. So let's see how we can do that for EVTX files. So it's going to be the same command like here, but this time the model is going to be dump files like this, and we're going to specify -a to preserve the names of the processes, and then minus process ID, minus directory, capital D, file handles, that's my folder name, so that everything over here that eventually this process ID has handles to will be extracted to that folder. So if it has a handle to the file, it's going to be in that folder. Yeah. So as you can see very quickly, we've got over here EVTX is coming. Yeah. So these are the ones that we will be interested in. Later on, there's going to be a list of DLLs right now. But eventually, we're able to see here that we actually had a bunch of DLLs. So this is good. Now, question is, what comes next? Well, over here, this is this folder we are looking at. Yeah, so file handles. I'm going to be actually analyzing the application log. So that's this one. Yeah, and I'm going to allow myself to get that file, and actually I'm going to paste it into the tools folder so that we can analyze it one-on-one and it's going to be a very clear, so to say, situation, okay? So let me show you how we are able to, first of all, open this file. So that's going to be on the first lesson over here, and if we're actually able to do it. And the second, basically, how to recover it. So that's this file we've been working on. Now, if we do rename, and I'm going to remove this extension to leave only EVTX, so that's the file directly extracted from the memory. I'll try to do it. Fair enough. Can I, for example, fix it? Yes, of course, and that's what we're going to do. So please have a look. We're going to get into the Tools folder. Here we go. And we've got a folder over here called Out, and it's empty. So that will be the folder where we're going to be extracting our log file, okay? So CQ EVTX recovery, it's one of my favorite tools, to be sincere. We give an input directory and we give an output directory. So this is actually quite easy. Enter. And then it says successfully recovered 17 records. Well, that's exciting. If we have a look over here, we've got file. Let's see if it opens. And in a moment, we need to load it. It takes always a bit of time, so no worries about that, because it has to actually verify if we've got different types of internal signatures, and also signatures of chunks and so on. So there's a plenty of security in EVTX. But as you can see, this time we were actually able to open that log. So this is a fantastic way to fix and extract files, but also to fix corrupted EVTX files. And if you ever been going to be in that situation, don't forget that we've got a tool for it, and it's a free tool. Okay guys, so right now you are familiar with the possibility to play with the memory dump. Now it's time to look at the different ways of how we are able to extract evidence from the disk. So once, for example, you gather memory as for evidence, it's time for disk. So make sure that you're gonna do it safely using the appropriate tools like FTK, Imager, and so on, so that eventually nothing is affected. Let's have a look at the attack. So I'm excited because after this attack from the disk, we're gonna learn what actually happened. Let's have a look at the simple attack where we're going to deliver SMB relay. SMB relay in general is relying on the situation where we have no SMB signing in the infrastructure, and at the same time we're using NTLM version 2 protocol for authentication. Now this attack works in the vast majority of organizations, and the problem is that, well, it's easy, but at the same time there is a certain code that needs to execute. And it would be great, of course, to know what are the ways to figure out that that particular code has actually executed. So for the SMB relay, I'm going to use SMB relay X Python script, as you see, and my target is going to be 10.10.10.250. And on execution, I'm going to run CQ shell 104a.exe, which is actually a reverse shell that is customized by our team. Now, the customization that is happening here is actually related with the discovery or non-discovery by the antivirus solution, but at the end, it's just a simple reverse shell. So that's going to be the first step. Second step that we got over here is related with the listener or handler for the incoming connections. And I have over here Metasploit, which I have simply set up, as you see, that's everything. So that's why this attack is so simple, to perform the handling of connections that are about to come if they run the reverse shell. So this is basically what's happening here. Now that reverse shell in general is going to be running next because SMB relay itself, in order to establish a connection, to assure the session and so on, has to run its own executable, which we would like to trace afterwards. And that's going to be a very interesting situation to have a look at. So let's see. First of all, here we would just need to go exploit. And second thing here, we just need to run the script. Now, what I'm going to do on my side, it's going to be basically the query from a certain type of machine, so from one host to another, in order to query or trigger NTLM version 2 authentication. Now that situation is actually quite straightforward, because querying by IP address different types of hosts in the infrastructure, it's quite a typical thing, right? So basically we do / and then we specify IP address. Now I'm going to here listen to incoming connections. So please have a look. Now I have queried a certain IP address in the infrastructure. Here we can do PS to list processes, and over here I'm able to see that, for example, there's an SVC host running as NT authority system, which has process ID 3136. So let's do that. Migrate 3136, and the migration process over here allows us to move our bad piece of code to that process, and this is a typical exploitation technique, not in the form of DLL and so on, but by modification of the memory address space of that process. Now we are right now in that system, so if I press shell here, if we do who am I, you are able to see that we are actually system in that target system. So this is all good, but the question is, of course, how are we able to investigate that? Okay, and this is something that I would like to show you. So we were migrating the 3136, and we are able to see over here that it's from 2909. And once we did shell, then basically here there has been process created. So let's have a look how this activity reflects basically on our target machine. And it's extremely interesting because this particular attack can happen pretty much anytime. But the thing is that if it happened, for example, 6 months ago, now question is, how do we know that that actually happened? And there are a couple of things that could indicate, even after that time, that there is something bad going on. So first of all, what we're going to do, we're going to look at the machine. Yes, so let's do it. So here is the machine. We can sort by the process IDs for the simplification of this research. This, by the way, it's not because there is some vulnerability or anything. No. This is how it works because of the NTLM version 2 and SMB not being signed, which is a default actually. So here we go. We've got 3136, 3136. We actually do see that process. So we got 3136, yeah. So this is basically the one that we are migrating to. So I'm going to move down a little bit. So this is this one, 3136, but we don't have 2904. If we look for 2904, that process does not exist anymore. Now why? Because when we migrate to 3136, that 2904 just vanished. Yes. Now 2864, that is this one basically. It is here. We've got this one. That's the cmd.exe. Yes, indeed, because that's the shell. But of course, if the hacker closes it, you won't see it anymore. And now what? So, long story short, first of all, we can have a look at netstat. And with the option ANO, maybe, let's do more. And here we've got process IDs that are related with the communication. Now, funny fact is that if you have a look at the established connection, because it clearly stands out, we're able to see that the process ID assigned to that connection is 2904. But hey, didn't we just say that that process just vanished? Exactly, because unfortunately netstat won't tell you the truth. Netstat unfortunately will show you only the connections or the process that was used when we were establishing a connection, and that's it. So simply we cannot trust it. So is there someone to trust in the operating system, assuming that that attack happened long time ago? Well, yes, we've got something that basically we call prefetch. And within Windows Prefetch, which is out there running for all the time, we've got a possibility to verify what were the processes running since you have set up your Windows. So let's do start dot. And here I have sorted these things by date modified. So you are able to see that eventually we've got more, netstat, process hacker, who am I, and then we've got this strange guy. That's this IYJR and so on. So this is quite interesting because it looks dodgy, but of course it might have a really nice name. So let's, in general, for the sake of our research here, verify if this could be this bad process. So what I'm going to do is I'm right now on the hacker's machine, and this is this attack that we were delivering. Yeah, and over here you can see that authentication was made, and then we've got uploading file IYJRD and so on. So that's this one, and that was also the one that we could confirm that was on the client side. Yeah, so this is basically this situation. Now, if it was called who am I, for example, or Notepad or something, then it won't look that strange. So how can we look inside? Of course, shift right click, copy as path, and over here I'm going to go to our tools, where I'm going to use CQ and in this case Prefetch Parser. So in our team we've got lots of tools like that, but this particular one we're going to use with the parameter f for file. We're going to paste the path, and then we're going to do -a for analysis. And long story short, let me make a full screen. We are able to analyze a bit of details about what's going on inside the prefetch file. For example, here we've got run count 1. And run count 1 indicates that this particular executable has been running only once, and that is already quite suspicious. We can see when, but we can also see what kind of DLLs are loaded over here. So if this file has a name Notepad and it is actually malware, then we are always able to compare, for example, the list of loaded DLLs, whether it's the same as original Notepad or not. So Prefetch in general allows us to indicate what kind of executables were running in the operating system, even though process tracking, for example, as one of the logging methods, wasn't turned on. So Prefetch, it's not that detailed, but in a worst case, it helps you to understand if there was something suspicious actually running on your machine. How long do we maintain Prefetch? Well, since you installed Windows. So over here, you are able to find a history of everything that has been ever running in this operating system. That's one thing. Second, who can delete it? Well, Prefetch can be deleted by administrators. So long story short, if hacker knows what he or she is doing, then this person can go to the Prefetch folder and then eventually delete that trace. So it really depends on the situation, but actually, during this analysis, we rarely see that Prefetch is being deleted. What if it is deleted actually? Is it possible to recover, for example, deleted files? And answer is, of course, we can always do that. So this is always quite exciting, I would say, because there are different ways of how we are able to delete or hide files and so on, so that we can later recover them. Let's have a look at that moment at the demonstration, where I would like to show you how you guys are able to actually play with files that were deleted. Now, if you have any questions, of course, do not hesitate to post them on the chat, because this is quite an intense session, so I'm happy to answer those. But in the meantime, we're going to learn how to use PowerShell And that's exciting because PowerShell is free with the free module of Power Forensics in order to recover that type of data. So Power Forensics in general, you were able simply to download from the internet, and once you set it up, you've got all of these commands available. So over here, I'm gonna set up the drive. So that's the VHDX for the demo purpose. And our goal is going to be to mount it read-only. So the reason why we are doing it this way, because I mean, it's a good practice to do it like this, but at the same time, we have to do it this way so that we are not affecting any of these files. Now, over here, you're able to see that that particular drive is simply empty. And our goal is going to be to play with various commands in order to, well, set up the module itself, and then, of course, to get information about what kind of stuff has been deleted. So we've got over here import module, and then we're getting the forensic file record where the object is actually deleted. So we got it, and let's play that. Let's play with this. Let's run this command. And we've got over here all of the objects about from the E drives that are there, but without a tag of being deleted. So our goal basically is going to be to add that part. Yeah. And this will indicate us, of course, files that were deleted. Okay, so we can see here that we've got p.exe. And that p.exe basically is an executable that we would like to get. And for sure, we need to get more information about that. But the record number that we got, it's 38. That's something that we call inode or index and so on. So there are various names for that, but that is actually our record number that we're going to be leveraging. So once we get more information about, we are able to read, of course, how big it is and so on, but this one in a moment, so that when we get a forensic file record in general for that particular file, we can see, of course, its metadata too. Don't forget that metadata, by the way, can be as well modified. So let's play a little bit with the p.exe, and over here you can see that we've got attributes, standard information, file name, data. We can see how big it is. We can see metadata. So this is all about a deleted file. Yeah, and we've got it also in data. So whenever we play with attribute over here, especially with the data, we can see basically that we've got over here data run that represents as data of the file. So as simple as this. And we can see basically that that refers to the file, of course, that has been deleted. So that data run, it's a data structure of the file, or data content, or in general content of the file. Yeah, there we go. So we can right now play and see what is basically within data run and where does it spread. So we can see over here start cluster, and that's this one. And we can see the cluster length as well. It's not also sparse. It is important, but we rarely see actually sparse files. But start cluster would be the one that we're going to refer to while recovering the file. But before we do it, we have to learn that basically that particular cluster size is X. And we don't know yet what's the cluster size to multiply by 130. That's why we're going to do get forensic volume boot record to learn that the bytes per cluster, it's 4096. And then we've got invoke forensic DD in file where we specify that particular cluster size. We've got an offset and so on, and we save everything into a file. So our goal over here would be to recover that data structure and to save it into, for example, out file CQ test. Okay, so this is quite simple, right? Because it's all in PowerShell, and we are able to stream out the data that we got on the drive actually to the place. So here we've got our drive. And our goal, of course, would be to recover that particular file. So let's do it. Yeah, we got it. We've got a file as well. And let's see, basically. This is basically a PuTTY, so to say. And this is a working file that we have recovered from the drive. If you wonder, is it possible to get a signature? Answer is yes, of course. Yes, this is like a further step. But right now we can see that that particular file has a description and so on. And if we try to open it up, we've got the PuTTY over here working. If the file is or isn't digitally signed, in general, our goal would be to learn more a little bit by cutting it off while we've got over here the data structure. So this is basically the setup over here. And if we want to do it, then basically we will be able to put it into the array and then cut off all the details. So this is basically the approach. Now, once we do it, we can check out if particularly the file has the digital signature. Okay, so we got it. And the next part is related with the summary and the tools. So hopefully you guys enjoyed what we've seen today, and hopefully it was an insightful. And at the end, you've learned basically how we're able to play with a memory dump, how to recover data, how to play with the disk analysis after the attack, and how to get access to the deleted files. Whenever what is the next step to do, for sure, is to write a good incident response plan. Because every moment we are having that kind of stressful situation, it's always very hard to react. That's why, in general, we have to be ready and to have appropriate toolkit in order to gather evidence so that we've got a nice analysis like we did today in your situation. Don't forget to get the tools. They are all free. And within our blog, you are able to find more information about what we do in general in our team, including lots of free content because our team is very passionate about it. Thank you so much, guys, and hopefully see you on the next presentations.